You're just telling me you didn't do the homework. That's what you're saying right now. Because on try trig 1, there was a segment problem. There was one problem. It tells you what the segment is, and then you find it. In the next problem, you do the same thing except you found something else, and then you got it again.
Where's the confusing?
The segment of a circle, though, not the segment of a line. A segment of a circle.
You don't know what he said. Like, you see how I got it confused, right? No.
No.
Sector sounds like a segment.
What is it?
Yeah, what is a C?
So, popcorn sounds like poop. Get those two confused?
If you just learn English, you might mix them. Never mind.
Okay, we have to clear up everything today. I'm telling you right now. For those of if you're not, oh my God, if you're not practiced, a lot of crying tomorrow. Number 1. My pretty. Maybe number 1, if I gave you the picture, you know, this is the easiest problem ever. I don't need, in fact, starting from next year, I can take it out. Okay, look, a ship is going north 12 miles per hour. So here's the ship. And then it spots an island. So it's going north like this. Then it spots an island angle of 17 degrees to the east of the course. So here's the ship, here's the island. That's 17 degrees. Then 10 minutes later, okay, the ship is here. What do you want to call it? T. Now the angle is 28 degrees. How far away is the island at that moment? Right there, find x. Do we know what this is? Yes, if the ship is going, 12 miles per hour, then in 10 minutes, that's 1/6 of an hour. Isn't this 2 miles? Yes. How do you find x? Law of sines, right? Because you know 2 angles. Because if this is 28 degrees, what is this? 152. And of course, that's 106. So isn't this 11 degrees right there? Yeah. So x over sine 17 degrees is equal to 2 over sine 11 degrees. That's like easy. Cross this problem out. That's so easy. Okay, there will be nothing this easy tomorrow. Nothing. Okay? That's not even an appetizer. What is that? That's like the crackers when they give you your soup. That's what it is. Okay, does everybody can do number 2, the ambiguous case. This problem is on the test. Or should we just do it? Then how come we didn't do it yesterday? The ambiguous case one, look.
Because you did it. It's the same thing.
I did it?
No.
No, I didn't do it yesterday. No, we're going to do it just to get it on video because some of you are in so sad shape, it's not even fun. Now, like I told you, well, actually, if you use the law of cosines method like I taught you, you don't even have to draw this picture. But if you're going to use the law of sines method like you did last year, then you need to draw this picture. So this is A, 35 degrees. So always draw the angle on the lower left, and then this would be 6 and 8. Put the 2 sides that you know up there. Didn't I tell you guys this? Yeah. So what you have to do is find side B and angle B. Okay, I'm not going to do the law of sines method because that takes too long. Just use the law of cosines and everything just comes out. Okay, so if I'm going to use the law of cosines, how do I start this? This is the only angle you know, people.
Squared.
Yeah, 6 squared equals b squared plus 8 squared minus 2b8 cosine 35 degrees. Correct? Okay, and solve this equation. How do you solve any equation on your calculator? Make one side 0 and graph it. So on your calculator, you go y1 equals x squared plus 64 minus 16x cosine of 35 degrees minus 36. And if you want to add the 64 and the 36, negative 36, you can. But your calculator doesn't care, right? Graph this on your calculator. See, the ambiguous case, you know, if you use the law of sines way, you got to draw in the altitude and you got to figure out how many solutions there are before you even start. But if you use the law of cosines way, you don't need to know that. You just look at the graph and that tells you how many solutions you have. So if you graph this on your calculator, does it matter if it's radian or degree mode?
Yes.
No, this one doesn't matter.
Wait, but I did it in radian and it came out.
Yeah, I know, because it doesn't matter. You can be in degree mode, because you're not graphing any trig functions. Yo, Mr. Park, I see a cosine, but that's cosine of 35 degrees, which is a number.
Oh, but
Cosine 35 degrees is like 0.8 something, it's just a number.
Wait, if
I
you're
only
using
got
radians,
one
wouldn't it think cosine of 35 radians?
That's why you have the degree sign.
but when I was in radians, it didn't come out.
Yeah, because then you put, that's 35 radians.
Yeah, so it has to be in degree.
No, if you put the degree sign, it doesn't matter.
Where's the degrees?
No, the mode.
In-
The mode.
Okay,
I put it because.
if you're in degree mode, good, because then it's going to go cosine of 35 degrees.
Yeah.
But if you're in radian mode, it's going to go cosine of 35 radians, and then that's a -8.
So you want to be.
If
No,
know,
just
you'd
put the
have to
degree
convert
sign
it.
in, you don't have
You'd
to worry.
convert it.
Oh, I don't know.
Okay, well, tomorrow you better know. Okay, now, if you graph this on your calculator, you're going to get a parabola opening up. See how there's two answers right here? Here's one and there's the other. Remember I told you guys this? And what if you graph it on your calculator and the graph looks like that?
One solution.
Then there's only one answer. How come that's not an answer?
Negative.
Because it cannot be negative. Or, what if you graph it and the graph looks like that?
No.
Then there's no solution. See, so you don't, if you use the law of cosines method, it's so easy. But you watch tomorrow. I know some of you are going to use the law of sines. All hell's going to break loose because we have an obtuse angle. What does that mean? Just use the law of cosines and nobody will get hurt tomorrow. Okay, now, we have to find b now. Now notice that x represents b, yeah? So when you calculate this first x-intercept, that's the first b. Because remember, there's two answers. One where it's like this, and the other one, you can swing it on this side. It looks like this, right? So that's one triangle, that's the other triangle. See, 35 degrees, 8 and 6. We have to find b and b. Okay, so obviously this one is the smaller one, and this one is the bigger one, yeah? That's dull, right? But see, if you're smart, look, once you calculate the 0, x equals, see this number is now stored in x. So x is b now. Okay, now, once you know this side here, how do I find this angle right there? No! See right there, that's a 6-point error tomorrow. You use the law of cosines because you don't know two angles.
But you have B. Like you know what B is, right?
Yeah, that's this thing right here. No. You only use the law of sines when you know two angles, AAS or ASA. Do I know two angles in that triangle?
Isn't that an ambiguous case though?
Yes, that's what we're doing.
Yeah, but in an ambiguous case you can use either one.
Oh, no. Okay, no. Challenge you. No. I'll tell you. I
remember
challenge
these
you.
laws of science the last time we did.
Yes, but I showed you two ways.
No, I mean once you have it.
Just believe me. Use the law of cosines and nobody will get hurt.
You just try.
Okay, Huang, tell them what happened when you use the law of sines. One of them came out wrong!
No.
Yes or no? Yes. Ask somebody who actually tried it. It comes out wrong because one of the angles is obtuse.
Wait, no, we're saying that once you have
B.
then why
B,
can't you use the law
you
of
can
sines?
use
Because you don't know two angles.
Yeah, but you know
Okay,
two sides.
no.
But you have
Okay, this is what we're taught. If you know two angles, then you use the law of sines. Okay, how many angles do I know here? One. Don't use the law of sines.
I did,
Don't use the law of sines. Wait,
but I did this.
don't use the law of sines.
Can you just explain why though?
Because I did explain it. I did explain it. Okay, no. Okay, I'm thinking of an angle in a triangle. I'm thinking of an angle. Okay, I'm thinking of an angle in a triangle, and the sine of it is a half. Tell me, what is that angle?
There's pi over
30 degrees.
6, pi over 6.
No, it's 150 degrees.
No, but
Oh, because
no,
there's more than one.
let me just try it.
Thank you.
There's
Let me
more
just
Thank
try
you.
it. Let me
Right
just
there.
try it, okay? I'm gonna try it.
Just use the law of cosine. So once you get this, which is stored in x, just use the law of cosines. X squared is equal to 8 squared plus 6 squared minus 286
Let's B.
cosine of angle B.
Let's B.
And then you use this equation to solve for angle B. B is this one.
Wait,
Yeah.
But
What
what if
what's
the
a
obtuse
numerical
angle for the
value?
other angle?
Yes.
So you could find both of them then? If you do
That's what
the
you have to
opposite?
do tomorrow. You're going to have to find both. If you only give me one answer tomorrow, you probably only going to get 1 out of 8.
So if you use the law of sines, you would get both of them in one step.
But one of them's going to be wrong.
I got
What?
both
How?
of them right.
Which way did you use?
Fine. I didn't-
Yeah, but you did it the way I taught you the first time, right?
I don't know. I didn't think there were sine 35 equals
Okay, and then
sine zero.
now then you calculate this 0. This is this B. That number is now stored in x. And you know what all you have to do? Okay, here. Look, you guys are so I don't know what. Okay, let's solve for what is it? 96 cosine B is equal to 64 plus 36 minus x squared, right? So cosine of B is equal to 100 minus x squared over 96. So therefore B is equal to cosine inverse 100 minus x squared over 96, correct?
Yes.
Okay, so once you calculate this value of x here, you plug it in there, boom, that spits out the first angle B, this one.
Whoa.
Once you calculate this x, you plug it in here, boom, it calculates that one. How come it doesn't work with sine? Because that's an obtuse angle. I don't. Because if sine
comes
of
out,
an
Mr.
angle
Mark.
is a half,
It comes out.
it could
comes
be
out.
30 or 150. How do you know which one it is? That's all I have to say.
It comes out.
You okay? Okay, no?
What's your type?
Okay. No. Okay, let me ask you this. How did you get the 95.114 degrees in? If you use the law of sine?
Because okay, wait.
No.
Are you erasing?
You know, we did this last year. Okay, we only got like so much time. Okay, we gotta move on here. 3. Okay. Did we or did we not do a problem just like this? We're not learning!
Is this the mama bear one?
Yes!
Mama bear.
Mama bear baby. Okay, tomorrow, this I'm telling you right now, this problem is on the test. Weak version. The picture gonna look just like this tomorrow. Okay, all you gotta do is remember, mama bear, baby bear. Use the law of cosines on the baby bear, and then use it on the mama bear, and then all is well, all is right with the world. Now, the first 4 problems, no calculator. The last 4 problems you can use calculator. So this is the no calculator portion, okay? Use the law of cosines on the baby bear. Go!
X squared.
X squared equals 7 squared plus 5 squared minus 2, 7, 5 cosine theta. Now use it on the mama bear. 4 squared equals 8 squared plus 7 squared minus 2, 8, 7 cosine theta. 2 equations, 2 variables, solve it, and you're done. You don't remember doing the mama bear and baby bear yesterday? Morris is trying to absorb all he can, right? I'm telling you, if you don't practice getting the thing on your calculator, you're going to be crying. You want me to finish the problem?
Yeah.
Okay, 56 times 2. So 112 cosine theta is equal to 64 plus 49 minus 16, which is 97. So cosine theta is equal to 97 over 112. Can that be reduced?
No.
Yes or no?
No.
Feels like we did something wrong.
I got
33, 97,
yeah.
112.
That's right. 97 over 112 is cosine.
Okay. Then once you get that, you plug it in here. This is 97 over 112.
Okay.
And so x squared equal here. X squared equals, what is this? 49 plus 25 minus 70 times 97 over 112. How do you reduce that? Can 7 go into 112?
14.
Yes, so 7 goes into that 10, 7 goes into that 1/6. But 10 over 16 is like 5 over 8. Is that right?
Yeah.
So we got 74 minus, that 5 times 97 over 8?
Yeah.
Is that the right?
Yeah.
What's the answer over here?
Which should.
Oh yeah, okay, yeah, it's gonna come up. It's gonna come up.
Are you sure?
So just simplify this and square root it, you'll get the answer. I'll give you a hint, make a least common denominator. Okay, this problem, this is, look, bit of star or something, this is on the test. But you know it's gonna be kicked up a notch, right? You know, what can he do to get kicked up a notch? Okay, next, number 4. Oh, very good, everybody got it, because that problem's on the test. Well, I already told you, I'm going to give you a quadrilateral. You got to find the area. Okay, number 5. How many times have we done number 5? Not enough, apparently. Okay, here's theta. Find this angle so that the area of the segment, this is the segment now, tomorrow. If you don't know what a segment is tomorrow, too bad, because I'm not telling you. Find this angle so that the area of the segment is equal to the area of the triangle. Okay, let's call this R for the radius since we don't know what it is. How do you find the area of this segment? The sector minus the triangle. How many times have we done that, right? What's the formula for area of a sector? 1/2 R squared theta minus the area of the triangle is 1/2 AB sine C. Not cosine C, sine C. That's what I'm going to give you the formula tomorrow. And that's going to equal to the area of the triangle, which is 1/2 AB sine C. There's your equation. Divide through by R squared. How do you solve any equation on your calculator? Make one side 0. So y1 equals 0.5x. Bring this over. Minus sine x. Oh my goodness. Look, -1/2, and then you minus 1/2 is -1. How do you graph this on your calculator? Where it crosses the x-axis, that's your answer. Does your calculator have to be in radian mode in this problem?
No.
Yes. If you are not in radian mode, you're probably going to lose 6 points. Probably. You have, this one, there's no choice. You have to be in radian mode in this problem. And then please set the window. What is x min and x max in this problem? 0, 2. Look at this picture. What's the biggest this angle can be? No. 180, so 0 to pi. Because some people, you guys are still pressing the graph button and you just pray you see something. 6. Hey, how come you guys could do 6? Strange. Okay, 7, I think we need the whole board. Okay, number 7 and number 4. How come you can do 4 but not 7? You guys are strange critters. In quadrilateral A, B, C, D, D is 70 degrees, C is 80 degrees, AD is 5, BC is 6, and CD is 7. Find the area of this quadrilateral. Okay, now you got to draw in a diagonal. Which diagonal? Does it matter in this problem? No, this one doesn't matter because remember before you draw in one, you have a right triangle or an isosceles. But this one, there's nothing. So you just pick one and do it. Go.
AC.
AC. Okay. Okay, what's the area of this first triangle? That's easy. 1/2 AB sine C. Should my calculator be in degree mode or radian mode? Degree mode in this problem, because you're not doing any graphing. Okay, now, how many points do we get for that?
1.
1, you're right. Because you didn't do any work. Okay, how do you find the area of this triangle though?
To find the side and the angle.
Yeah, 1/2 AD sine C, which means I gotta figure out this side and this angle. gotta do some work now. Okay, so how do I figure out, let's call this side x then. How do I figure that out?
Law of sines. Or no, law of cosines.
I challenge you to use the law of sines. You cannot use the law of sines because you
Yeah,
only
yeah,
know
no, I
one
was thinking-
angle.
I was thinking
You only know
law
one
of
angle.
cosines.
Cosine.
Law of cosine. So to figure out the side, x squared is equal to 5 squared plus 7 squared minus 2, 5, 7 cosine 70 degrees. Punch this in on your calculator. Don't forget to square root it now.
7 point.
And then store that in x, because you got to use it in the next computation. Or whatever letter you want, store it. Okay, now we got this side. How do I figure out this angle? Well, if I can figure out this angle, you just subtract it from 80, right? Okay, what do you want to call this angle? Okay, let's call it y then, whatever. How am I going to figure out y?
Law of sines.
Oh gosh, you guys are killing me.
No, because we just found out.
You only can use the law of sines when you know two angles. In this triangle, do I know two angles?
No, what angle?
Thank you. So you should use the law of cosines. However, if you know for a fact this angle is less than 90 degrees, then you can use the law of sines. So you can use it. How do we know this angle is less than 90 degrees?
It's part of
Yeah, because it's less than 80, duh. But see, I'm reluctant to use the law of sines now because some of you think you're going to get to use it tomorrow, and you can't, and you're going to get a -6. But I want to use it because I know it's less than 90. But tomorrow, some of you not going to know it's less than 90, and then you can use it -6. So what do you want me to do? Law of sines is easier.
Cosine.
If you can use it.
Cosine.
No,
sines,
Cosine.
sines,
Cosine.
Sines.
Cosine.
Sines.
Okay, you can do either. You can do this. Sine y over, what's opposite from it? Some of you don't even know you're supposed to look at the opposite thing. 5 is equal to sine 70 degrees over x, but we have x stored already. So now you can use this equation to solve for y. Or you can use the law of cosines, which is what you're supposed to do. 5 squared is equal to x squared plus 7 squared minus 2x7 cosine of y. So you can use either of these two equations to solve for y. See, if you use this equation, you have to know that y is less than 90 degrees. This one, it doesn't matter, because even if it is greater than 90 degrees, it's going to come out. Some of you still don't get that yet. Maybe when you see the -6 on your paper tomorrow, then you realize it. I don't care what you... I'm telling you right now, this is the safe one, okay? Because tomorrow, what if I make that angle 120 degrees?
Oh, cosines.
Then are you going to know it? It could be bigger. You don't know. Okay, whatever. So whichever one you use, store that in y. That's angle y now. So now how do you figure out the area of this triangle? 1/2 AB sine of C. And what is this angle? 80 minus y. Press the enter button and thing will just spit out your answer. You guys know how to store things, right? I'm assuming. But you know what happens when you assume, right? You make an ass out of you. When you assume, you make an ass out of you. No, not me. Well, we'll just see what happens tomorrow. And then are we, well, that's it. Okay, so,
Could you do a,
so 3 of the problems come from inverse trig, all no calculator. And 5 of the problems come from tri-trig. 1 of them no calculator and the other 4 calculator.
could you give us a practice problem like number 8 on tri-trig too?
So. And anyway, you guys finished that yet? Oh, gosh. You guys are just playing with fire. Eh? So no questions then. And I'm giving you hints on, not only am I giving you the formulas, you got hints on 4. Okay, let's practice. Let's practice a problem for tomorrow. Okay, let me think. Shh. Solve for x. Oh, I need my pen. Okay, just don't look at what I'm doing. Shh.
What is you not getting that? Like, you're gonna erase. Let's go. You don't even know what to do.
Even though the second.
That's because it sounds so
No.
good.
It's
It
not
sounds
even
like.
that.
No! What time is it?
1:23.
Silence. Sit on. Oh, darn it.
We're getting a new laptop.
Okay.
Are you lying? Brace you and Royce for when I leave and you guys don't know anything.
You never see you're gonna be gone. What day?
I stopped coming after for exams, but then I'll wait until like end of the 2 weeks.
Oh, we're just not go to school. Oh, we just not.
Yeah, I'm not going to school.
I can't think right now. I can't think.
It's more.
So what kind of fees do you pay?
Huh?
What kind of fees do you pay?
Okay, here. I got it, I got it.
3 hours?
You did that.
Do you have weekends?
Okay, let's do this.
You know, for weekends?
What? Yeah, yeah, we
What do you do on the weekends though?
can. Free time.
Can't drive in
They have the metro.
there. This is.
Now remember how I told you to do this problem?
Yeah.
You can draw the picture and you can guess at the angle, but you don't even get 1 point. You gotta show the work. You wanna guess first or do the work first?
What's triple angle?
There's no triple angle here.
You just combine two of them.
Morris, this is like the 3rd time you've done a problem like this.
You just combine.
Yeah, bring one of them on this side so you only have 2. Okay, we only got 2 more minutes. Where is Takaki? You only get. You were supposed to finish 20 minutes ago. I told you 22 minutes.
Waiting for you to call me.
I'm not gonna call you in. Not when you're taking a quiz. Okay, which one you want to bring over?
Two.
Okay. Period. All hell is breaking loose already. Okay, obviously we're going to tan both sides. So, tangent of the first minus tangent of the second, all over 1 tangent of the first, tangent of the second. Tangent of the first plus tangent of the second, all over 1 minus tangent of the first, tangent of the second. Shall we simplify this? 13 over negative 39. Should I reduce? Oh, I remember I gave this problem 1 year. And you know what happened? They don't reduce this, and then when they start cross multiplying to get big numbers. People, that's negative 1/3. If you reduce, you get smaller numbers to work with.
Wait, how? Oh, wait.
13 goes into 39 3
Where
times.
did 10x go?
Tangent of the first is 5. Tangent of the second is 8.
Oh, on that side. Oh, okay. One sec.
Okay, cross multiply. 3 tan x minus 6 equals negative 1 minus 2 tan x. 5 tan x is equal to 5. Tan x equal 1. Okay, you get that tomorrow. You get that far, I give you 5 out of 8. You want the other 3 points, so you gotta tell me what that angle is. Oh, so easy, Mr. Park. Pi over 4.
No.
Wrong, minus 4.
But there's 3 of them.
There's only one.
No, I mean there's 3 of the
Seven
things,
pi
so it would be
over
big.
Yeah, so draw the picture. Okay, how do you draw an angle that's tan inverse 2? Opposite over adjacent 2 to 1, like that. That's tan inverse 2. Now add to that tan inverse 5, so make 1 by 5. 1, 2, 3, 4, 5. There, tan inverse 5. And then add to that tan inverse 8. So 1, 1, 2, 3, 4, 5, 6, 7, 8. There. That's tan inverse 8. Now add all 3 angles together. Does that look like pi over 4? No, so what's the next one then? 5 pi, so 5 pi over 4?
Yeah.
And Mr.
Yep.
Park, there you go. Mr. Park, are you just gonna give us those ones where it'll always turn out to be like the third one? This whole time
Show up tomorrow and you'll find out.
you've been giving us ones where it's like the first one.
Okay, Takagi, come here while I correct it. That's why you should have come this morning. That's why I come at 6:30. You come at 5:30?
7:30.